Hey, welcome to part 2 of the Rhino tutorial. In this part, what I'm going to be covering is two-dimensional drafting in Rhino, and I know you know how to do this in Autocad, but it's important to understand how to do it in Rhino as a bridge between the two tools, and so that you can make kind of like modifications to things. As I'm going to explain in one of the later parts of the videos, the foundation of three-dimensional modeling is really two-dimensional drawing and orthographic projection. So it's important to understand how to do this in Rhino. And so I've got a new file started. You can just go ahead and clear what you've got. I'm going to go to the top view. I'm basically just going to start drawing in some plans here, just as a way to understand how these different tools work. So like in AutoCAD, you know, the foundation of drawing is the line tool. And you can do basically the polyline is the line, and you can basically click and make points. Every time you click, you get a new line, and when you're done, you right-click or you press Enter, and that will actually stop the command. Just like in AutoCAD, if you press Enter, you will get the same command launched again. So you can go ahead and make more than one line. Also, pressing Enter will do the same thing. And you'll note that there's also snaps. So if I go back and delete these lines here, snaps are on the bottom here. If you don't have snaps, you need to turn on the O-snap toggle, or go under Tools, Object Snap, and make sure that Persistent O-snap dialog is checked, and that will turn it on. O-snap simply means Object Snap, but ones you need to know, there's End Snap, Point Snap, Midpoint, Center, Intersection, Perpendicular, Quads, Knots. These are for curves. Vertex, etc. Be careful with project snap, because that will project three-dimensional snaps into a two-dimensional plane, and that can make things confusing in 3D. Near snap will basically snap to darn near anything, so it's not really very useful for us. Again, it's not very precise that way, but if you have these snaps turned on, you can make things easier. Like if I want to finish off this thing, I can get the endpoint and snap to the endpoint, and I have a form. If you want to complete a form, you can go ahead and say join, J-O-I-N, and that will say one closed curve. It's important in Rhino, you have this little properties dialog. If you don't have that, you can press F3, and that will actually turn that back on. It's important because you can see if you choose an object, just like an AutoCAD, it'll tell you whether the object is closed or open, or if it's a solid or a poly surface. It'll also tell you what layer it's on, so that's really useful. You can also go to details here, and it'll say closed poly curve with two curve segments. So you're looking a lot of times for things that say closed or solid, because those are very precise, and those are the ones that are going to extrude properly and 3D print properly. And it's a sign of a well-crafted model. You don't want a bunch of loose garbage kind of in this line. You don't want a bunch of overlapping lines or lines hidden in this. If you intend it to be closed in one thing, it should be closed and it should be one object. Okay, so be really careful about that. A lot of times in AutoCAD, it's possible for us to have a lot of that garbage, and that's why I want to really point out the properties palette to you. We'll talk about this more in the next part, but it's a really important tool. But for now, I'm going to go ahead and close it, because it's not necessary right now. So we talked about lines, we talked about snaps. The other things that we have are access to different kinds of primitives. We've got different kinds of ellipses, circles, different kinds of rectangles. If you hold down the mouse button, it'll actually make all these different commands kind of spill out, similar to AutoCAD. Polygons, including stars, squares, different kinds of things. Polygons are very versatile, so I can change the number of sides that I have in a polygon. I can change it to a pentagon, or anything down to a triangle, basically. Again, circles and rectangles. And, as you note, they have all kinds of options for how you want to make them. You want to make them from the center, or from corner to corner, or edge to edge, or radius, diameter. There's all those options available to you. I won't really go through those, but once you have those shapes, you can perform a lot of different commands that you may be used to. So I can trim, right? So I take a cutting object, and I can cut, part of an object away. I can do more detailed, trim. What I'm left with needs to be joined together, so I can select everything. Now, you can, if you hold Shift, it'll add to a selection. You can also just drag the mouse. If you want to deselect something, just Control click on it, and that'll deselect it. Okay. You can also do select inverse. So if I select everything, I can go edit, select, invert, and that'll invert the selection. We'll use that a lot later on. So I can go ahead and join these. Once again, they're a closed object, so that's really important. Besides trim, there's a split, which means I can choose the object to split, choose the cutting object, and that's actually going to split this into two pieces. We'll use that later on. These commands are actually, they apply both to 2D and 3D, which is why I try to explain them. Anyway, so experiment with those commands. Get a feel for like where the tools are, the way they operate in Rhino, and then go ahead and look at something else here. So I'll make some other objects here. So the other commands that are really important are called transforms. We've done some of this in AutoCAD before. The three transforms are move, rotate, and scale. Move you can accomplish by simply picking an object and dragging it. If you just want to kind of drag something, but if you want to have more precision, you want to launch the move command. That's MOVE. You can choose an object, and then you can choose where you want to move it from, and where you want to move it, to. And you can type in coordinates for that, so I can move these to the origin if I want to. Okay. The other commands, right, are rotate. So I can rotate an object, and you can specify an angle. So I can say rotate this 45 degrees, or I could say rotate, and I'm going to make this my reference angle, and I can rotate, by sight. You can use the orthographic snaps as you did in AutoCAD to get a constraint to 90 degrees. You can also do polar constraints. You can change the angle. There aren't polar snaps, I guess, the way that there are, but you can change the ortho angle to be anything, so 15 degrees or something if you like. Anyway, so rotate is another option, and then finally scale. And scale, you can set an origin point. You can type in a scale. Scale factor 2 would be 200%. Scale factor of 0.5 would be 50%. You can also scale by reference. So if I click and hold Shift to get to the edge, and then I drag, I can sort of visually scale. You can also do a non-uniform scale, or scale in U, which scales in one dimension. So the origin point, again, it would be here, and then I can scale on the X, so I could scale, the long way. I could also scale the Y or the Z, so again, something pretty similar to the way we've done things in AutoCAD. The other commands really useful is hide and show. Oftentimes, models get really complex, and we don't need to see everything at once. We only need to focus on the objects that interest us. So a really important idea in computation is to basically hide the things you don't need, right? So if we go and we can say hide, then I can kind of focus on this without worrying about accidentally selecting something else. And then when I'm done, I can say show, and that will show everything that's been hidden. It's pretty much binary. I mean, I can keep hiding things. I can say hide, hide, and then show will bring them all back. Okay, but I can't get very much more granular than that. So things are either hidden or they're shown, and that's that. But that can be very, very, very helpful. Okay, so the last thing I want to show you are just some of the more complex transforms. So I can do things like mirror something. Oops. So I'll take an object, and mirror it across a plane. Pretty simple. I can choose whether or not to delete the mirrored copy. I can do operations like offsetting lines. So offset. Again, being careful to make sure I'm using the right units. So if I want to offset a 1/4 inch, I could do an offset distance of 0.25 or offset 1/2 inch for 0.5. And then you can choose which direction. See if I zoom in here. So do I want to offset to the inside or offset to the outside? You can do this with shapes too. You can offset. So all the stuff that you're used to doing in AutoCAD is basically here. It's really good for you to get familiar with that. The other thing, the last thing I want to talk about is layers. It's always good to keep organized, and it's good to maintain that layer hierarchy. And so you can do layer, and that'll pop up the layers tab. That's also you can also turn it on with F3 and then go to layers. You can also access it here if you just want to quickly change the layer or something. But if you go to layers palette, Rhino defaults makes these layers, these 5 layers with 5 different colors. You can edit those, or you can make your own. So you can just say new layer, and you can say like lines. And the color is actually, it will determine the color that it shows up in the viewport. It's not actually a material. It doesn't actually render that way. It's just kind of a visual cue. To add something to a layer, you select it, and then you can say, actually here. And then actually, I guess you can just go through here, and that'll put it on a layer. So I could do another layer, or I could do shapes. It's a bad idea to make something yellow as a layer, because yellow is the selection color by default. And if you make something yellow, you can't tell whether it's selected or whether it's on a yellow layer. So be sure to make the other layer color something you can see. You can say let's see here, change object layer, and that will change the layer of the object. So besides just using the drop down here, you can actually go through and say change layer. Okay. Cool thing about these two is that if you want to select every object on the layer, you can right click and you can say select objects, and that'll actually get it for you. You can turn off the layers, you can turn on the layers, you can lock a layer, and then you can't select what's on that layer, but it'll still show up visually. Again, pretty similar to the way that AutoCAD works. Okay. Last but not least, you can import your lines from your AutoCAD file, and that's a very useful way to work in Rhino. And to do that, it's very simple. Just go to Open, and you are going to find your file. In this case, my file is called Base Drawing. And you basically don't need to change anything, except just be sure that you know what units you drew it in, and you know what units you want it to be in Rhino, and it'll make the conversion. And there you go. So my file is set to inches, and my lines have already popped in. You can see that I've already made my stuff in AutoCAD using our AutoCAD template, and so it's automatically basically colored by weight. It just makes it easier to read. So we'll stop here, but basically, you just want to make sure that you can import your AutoCAD file. Double check the units if you go into Measure Tool again. Should be a 4x4 cube, and your unit should be inches. Okay, if it's not, you need to rescale it in AutoCAD. Make sure that your units are in inches. Make sure it imports in inches in Rhino. Okay, once you've got that, go ahead and open up the next tutorial video, and we'll start modeling this thing in Rhino.